Have you ever wondered how files are organized in your computer? How do you find a document you saved weeks ago among thousands of files? Well, the answer lies in the directory structure that your operating system uses. Now, you might be familiar with the term folders, which is used in some operating systems. In essence, these are what we call directories. They act as containers that group related files and other directories, creating an organized and navigable file system. So when you're scrolling through your documents or your pictures, you are actually navigating through a series of directories. The directory structure is not just about storing files, but it also defines how these files and directories are accessed and how they are linked together to form a comprehensive file system hierarchy. It's like a well-organized library with books on different topics stored on separate shelves, making it easy for you to find the book you are looking for. Operating systems may implement different types of directory structures based on their design principles and user requirements. Some systems might use a simple single-level directory, where all files are contained in a single directory. Others might use a two-level directory that separates files by user, or a hierarchical directory structure that most modern operating systems use. There are also acyclic graph and general graph directory structures, which allow for more complex file sharing and linking. Each type of directory structure has its own strengths and weaknesses, and is chosen based on the needs of the system and its users. For instance, a single-level directory might be easy to navigate, but it can become unmanageable as the number of files grows. On the other hand, a hierarchical directory structure allows for extensive organization of files and directories, but it might be more complex to navigate. By the end of this video, you'll have a better understanding of how your computer organizes its files and how you can use this knowledge to your advantage. So, let's dive a bit deeper into these different types of directory structures and how they function. Let's dive into the first two types of directory structures: single-level and two-level directories. The single-level directory structure is the simplest form of directory organization. Picture a large box where you put all your files. There are no dividers or compartments, just one big space where everything goes. That's the essence of a single-level directory. It's simple, yes, but it's also a bit chaotic. The more files you add, the harder it becomes to find what you're looking for. Imagine searching for a specific document in a box brimming with papers. Not the most efficient, right? That's the challenge with a single-level directory. As the number of files grows, it can become increasingly unmanageable. Now, let's shift gears and talk about the two-level directory structure. Think about the single-level directory as a big communal box. In contrast, the two-level directory structure is like having a personal box for each user. Each user has their own space to store and manage their files. This structure is a step up from the single level because it provides better organization and security. The two-level structure isolates each user's files from one another. It's as if each user has a key to their own box, preventing others from accessing or misplacing their files. This isolation can significantly enhance security, particularly in systems with multiple users. However, while the two-level directory improves organization and security, it does come with its own limitations. Since each user's files are isolated, it limits the interaction between users' data. There's no easy way for one user to share a file with another user, as they would need to step out of their personal box and into another user's box. In summary, the single-level directory is simple, but can become chaotic as the number of files increases. On the other hand, a two-level directory offers improved organization and security by separating files by user, but it limits interaction between users' data. For a system with multiple users, a two-level directory structure can offer a more organized and secure way of managing files. Now, let's talk about the most commonly used directory structure, the hierarchical directory structure. Imagine a family tree. At the top, you have the root, the progenitor of all that follows. This is akin to the root directory in a hierarchical structure, denoted as /inch in Unix, Linux, and CT, or similar in Windows. From this root, branches extend, representing subdirectories. Each of these subdirectories can further branch out into more subdirectories, creating an extensive tree that stretches wide and deep. This structure is recursive in nature. Directories can contain files or other directories. The beauty of this lies in its ability to organize files based on various criteria. Whether you're looking to group files by type, purpose, or any other attribute, the hierarchical structure facilitates this with ease. Think about your personal computer. You might have a directory for documents, another for pictures, and another for music. Within the Documents directory, you might have separate folders for work, personal matters, and hobbies. This is hierarchical structuring in action, creating an organized, navigable system from what could otherwise be an overwhelming mess of files. It's a bit like a well-organized filing cabinet, where each drawer represents a directory, and within each drawer are folders, or subdirectories, holding related documents or files. This makes it easy to locate a specific document when needed. Of course, as with any structure, there can be complexities. The hierarchy can become deeply nested, with subdirectories within subdirectories, potentially making navigation a challenge. But modern operating systems offer tools to navigate and manage this structure efficiently. For example, you can use this cd command in Unix, Linux, or Windows to change directories, or the ls or dir commands to list the contents of a directory. These tools and others like them make it possible to manage and navigate even the most complex hierarchical structures. The hierarchical directory structure is the backbone of most modern operating systems, offering a balance of flexibility and organization. It's designed to facilitate efficient file storage, retrieval, and management, making our digital lives a little less chaotic. With its extensive tree of directories and subdirectories, the hierarchical directory structure makes it easier to find and manage files. Next, we'll explore the acyclic graph and general graph directory structures. Diving into the acyclic graph directory structure, it's essentially an extended version of the hierarchical directory structure. The key difference lies in its ability to share or link directories. You can imagine this as a family tree where, instead of each person having just one set of parents, they can have multiple sets. This might sound a bit unconventional, but in the world of file systems, it's incredibly handy. This structure uses features like hard links or soft or symbolic links in Unix and Linux systems. These links create multiple paths to a single file or directory. It's like having several doorways leading to the same room. This structure allows for flexible data access and sharing, without the need for duplication. It's a clever way to save space and improve efficiency. Now, let's delve into the general graph directory structure. This one is a bit of a rarity due to its complexity. In this structure, directories can have multiple parent directories, potentially creating cycles. It's like a web, where everything is interconnected and there are numerous ways to reach a single point. This structure offers unprecedented flexibility, but can make navigation and file system operations a tad complicated. Imagine being in a maze with multiple entries and exits. It's easy to get lost. However, despite its complexity, the general graph directory structure can be quite useful in specialized applications or environments, where a high level of interconnectivity is required. While these directory structures may seem a bit intimidating at first, they offer a lot of flexibility. They allow for more complex and interconnected file systems, which can be beneficial in certain scenarios. The acyclic graph directory structure, with its multiple paths to a single file, allows for efficient data access and sharing. On the other hand, the general graph directory structure, with its web-like interconnectivity, may be just what is needed in specialized environments. Though more complex, these directory structures offer flexibility and can be quite useful in certain scenarios. Finally, let's discuss the functions of a directory structure and some common operations. Directory structures in operating systems perform several critical functions. First and foremost, they help organize files in a manner that is both meaningful and logical. This organization makes data easier to locate and manage. Imagine trying to find a specific document in a room full of scattered papers. It would be quite a nightmare, wouldn't it? Now, imagine if those papers were neatly filed in labeled folders. The task would be significantly easier. That's precisely the role of directories. They are your digital filing cabinets. Secondly, directories allow files with the same name to exist in different directories. This feature helps organize and segregate data without naming conflicts. It's like having two books with the same title, but in different sections of a library. Thirdly, directories play a crucial role in permission management. They can have permissions set on them, controlling which users can read, write, or execute files within them. This feature enhances security and access control, making sure that only authorized individuals can access certain files. Lastly, directories enable grouping. Files that are related, whether by application, by user, or by type, can be grouped together in the same directory. This simplifies access and management, making it easier to work with related files. But directories are not just for storing files. You can perform various operations on them. For instance, you can create a new directory using the mkdir command in Unix Linux or md in Windows. Deleting a directory is equally straightforward with the rmdir command in Unix Linux, ensuring the directory is empty, or rd in Windows. To list the contents of a directory, you can use ls in Unix Linux or dar in Windows. And if you want to change your current directory, the cd command is used across different systems. Understanding these functions and operations can help you navigate your computer's file system more effectively. So there you have it. We've navigated through the labyrinth of directory structures, from the simplicity of single-level systems to the complexity of general graph directories. We've seen how they help organize our files, manage permissions, and facilitate efficient data access. Understanding these structures is key to effective file management, providing a roadmap to navigate our operating systems. Next time you save a file, consider how it's being organized and how you can navigate your system more efficiently. Thanks for watching.